Hello, everyone. Welcome to today's webinar. Today we have an exciting, slightly different webinar than our usual ones. We've joined by our partners from Laser Technology Inc. They are the manufacturers and producers of laser rangefinders such as the TruPulse. Before we get started, a little bit of housekeeping. So for those of you here in the live version of the webinar, please do engage with us throughout it. You can ask questions through the Q&A section of your GoToWebinar panel. You might need to expand it first. And for those of you in the future watching this off of our YouTube channel, we do monitor the questions. So please, feel free to ask one in the comment section below. Okay, let's get started. My slide would advance. So as most of you know, or as I should say, as hopefully all of you know, a topo surface is an essential part of road design. That topo surface can be created from a variety of different survey data types, including LiDAR data, total station, conventional surveys done with a compass and a chain out in the field. But you can also do it utilizing a laser rangefinder. And so that's really the purpose of today's webinar. We're going to talk about how to collect field survey data using the TruPulse 360 or 200 laser with a compass. So there's a bunch of benefits for using this type of equipment in order to collect your survey data. And when we compare it with other methods, it is a lot faster and cheaper in terms of the acquisition costs compared to total station and LiDAR. When you look at probably where we're seeing it used the most is when someone was looking at doing a more manual survey using a compass and a chain. And it is a much faster method as well, as it has the capability to reduce a lot of those user data entry errors that we might see. And there's also less equipment required. So you're looking at, having a laser rangefinder, so the 360R or the 200 model plus a compass, a Windows 10 device with RoadEng on it. So this could be a ruggedized Windows 10 tablet, it could be a laptop, and then a GPS, which is optional if you want to set those initial coordinates or georeference your traverse. So pretty much going to talk about this, passing it over to Derek Resch, who's the Senior Product Manager from LTI. And I should say we are going to be focusing today in the webinar a little bit more on forestry and some of the natural resource applications. We do have potential use in other rural infrastructure. That really just depends on your accuracy levels needed. But lots of potential uses for laser measurement outside of even just field traversing. But with that, I think, Derek, you probably can take us through a little bit more, give us a bit more of an introduction to how the laser works, and some of the applications.
Yeah, great. Thanks, Aaron. Really appreciate being here today and everybody online listening today. So with our laser rangefinders talking about, there's a lot of different applications that you can see here, just for different, we have a lot of different routines that are on board of our laser and all the different forestry applications you can see here with all these different diagrams. But we're really going to be focused on that surveying part. And so integrating with the laser rangefinders into RoadEng. So basically I want to talk about what are laser rangefinders. We do design, manufacture, and distribute laser rangefinders out of the Colorado area, and so we've been doing that for 35 plus years. So basically what a laser rangefinder is, not just a sports optics one. It's a professional laser rangefinder. We have all different sensors built on board, and the main one, of course, is the laser sensor that measures distances or gets us as our range to almost any type of object. So we call it reflectorless technology. No need to have a second person or a reflector at the target area. Press the fire button, gives us our distance to that object. And built on board of all our laser rangefinders is a tilt sensor. You can see here on the right-hand side, we do not have any tilt limitations of getting that vertical angle. So you can still do that plus or minus 90 degrees to get the vertical angle, which is helpful for us for our height routine and also for elevation. And it's very useful within this application. Then we have different models that have a compass sensor built in. So that's going to give us our azimuth measurement or direction. You can see the little gyroscope moving around there. What we're representing is there's no pitch or roll limitations with this either. I mean, you can get a very accurate azimuth measurement, even if you're, minus 45 degrees, or even if you have it on the side, you're still going to maintain the accuracy of the azimuth measurement. So what does that look like in a diagram? So here we have a couple diagrams. We have 2D lasers and 3D lasers. The 2D, we've got, again, measures the laser and the tilt. The laser is represented by SD, or slope distance. That's line of sight, so you need to look right at the object and take that, and you're looking right through the viewfinder there. The tilt sensor gives us our inclination, degree of inclination, so plus or minus 90 degrees again. And then when we put the compass in there, we get our AZ. You can see that on the right-hand side of the diagram, so we get the azimuth value. Now, once you press the fire button, all those sensors measure and get a value. And once we get those values, the laser will actually calculate a VD value, or your vertical distance value, and your horizontal distance value all at one time. So press the fire button, depending on the laser, the 2D or 3D, you get all these different measurements. And then with those measurements, it calculates the other VD and HD. And then we actually output that out a serial port or Bluetooth automatically. There's no other button press that you need to do that with to get these measurements out. It calculates and shows you everything in the heads-up display. You can kind of scroll through and see all the different values. We have different modes built on too. I talked about height, but one other mode I want to talk about is the filter mode. Especially, it's really good for this application. You know, I did mention it's a reflectorless technology, but we have an option on board where you can turn this filter mode on or off. And so what I mean by that is it needs to have a measurement to a reflector or a highly reflective material, such as these little prisms here, or 3M reflective tape. You can put that right on top of your helmet, you know, and be able to get those measurements. But now you have to have that position out there to get a distance to it. So like this picture on the right, you see that brush in front of the filter or the reflector there. We're able to get through that brush and pick up the prism and then give us a distance. Steve, do you have anything else to talk about the filter mode?
Yeah, it's Steve Colburn with Laser Tech here, the applications training specialist with the company. Yeah, just a real useful mode so you don't have to brush in certain cases. Or maybe you want to place a target right on the stem of the tree if you're measuring a height or something. No need to shoot through clear the brush. You can just shoot right through it, or with a survey target like this. And yeah, the multispectral reflectors are often better in the woods. These survey prisms will give you the strongest return for distance, but the multi ones like reflective tape or highway reflectors work better in the brush typically.
Yeah, thanks, Steve. Yeah, that's perfect. So just jumping in, what TruPulse models do we have? So our first TruPulse 200 series, this is our 2D lasers that measure distance and inclination that I've talked about. And you see two different models here, the TruPulse 200 and the 200X. You can see the specifications down below. The range accuracy of the TruPulse 200 is 20 centimeters, and we get out to 1,000 meters to non-reflective targets. And I talked about the Bluetooth communication, so this integrates great with Android and Windows, just like we're talking about today. The 200X, the specifications, we've increased those, especially on the range accuracy. We're down to 4 centimeters. And the range we can get to is increased out to 1,900. So you see the two different models. One other difference we've got is the TruPulse 200, you see that LCD display. And on the 200X, it's an LED display. So it depends on your application, your accuracy requirements, and kind of which model that it's best for you. We have with the TruPulse 200 series. When we incorporate the compass sensor, it's called the TruPulse 360 series. Aaron touched about this already here. The TruPulse 360R and the TruPulse 360. You can see the specifications are the same for both instruments. The main specification to take a look at is that azimuth accuracy. You can see that's down to a half a degree on the azimuth accuracy. And again, there's no tilt or roll limitations, and we still maintain that accuracy, which is great because the world's not flat, so you're taking measurements all up and down hills. The main difference between these models, the 360R is a ruggedized waterproof housing, and it's also kind of that binocular style, how you hold it versus the TruPulse 360. So which models are we talking about today that there's different laser integration within the RoadEng? Right now we've got the TruPulse 360 and the 360R are the two models that are integrated with the RoadEng, and you need to have RoadEng version 8 and newer. And so that's what we're talking about today. And before we get into the demonstration of the laser interface, Steve's going to discuss one of the most important things to do before you begin work in the field. So I'm going to go ahead and turn it over to Steve.
Thanks, Derek. Yeah, as we mentioned, you can use the interface with a TruPulse 200 and just use it to measure your distance and inclination, and then use a regular handheld compass to record the azimuth. Our electronic compass can get you a lot better accuracy and get you that electronic data transfer too. But it's just like any other compass, right? You got to be careful where you're standing. You got to make sure you don't have any, ferrous objects on your body or nearby. Strong EM fields, like radios and stuff like that. You really got to have a nice clean environment, just like any other compass. Now we've integrated in some intelligence in there to kind of help you out and let you know when the compass calibration needs to be done. There is for all the sensors, there's an indicator in there about what you're looking at, and there's an indicator in there that says AZ for azimuth. And when you see that start flashing every few seconds in the lower right-hand corner of the display, that means you need to calibrate the compass. Now, there's several things that may have happened. The temperature may have fluctuated greatly since you calibrated last, or the battery power may have dropped a certain amount, or you may have swapped batteries, and we detected a break in the battery compartment there. So when you see that AZ indicator flash, you want to do the compass cal. And then you also want to do it really anytime you move to a new site and get set up. It's real quick and easy to do. Let's get started and see how it goes here. Just takes a few seconds.
Hi, Steve with Laser Tech here, and I'm going to go over the compass calibration today on a TruPulse 360, 360R. I've got the R with me here. First thing I want to do is make sure I'm away from all magnetic interference. As best as you can tell, get out in the middle of a field, wait till you get out to your project where there's no machinery around, things like that. That's the best place to do it. Get into the compass calibration menu in the settings routine and get to where you see C1 FD, C1 forward on the screen, and then what you want to do is face or orient the compass so you're pointing north. This has got to be within, plus or minus 10 degrees or so of north. You can use even an uncalibrated compass reading on the laser to find it. But face north, point the unit north, and then take your first calibration point. And then you just rotate 90 degrees for each point. There's number 2, number 3, number 4. Bring it back, rotate it 90 degrees. Number 5, number 6, number 7, and number 8. Now you want to look in the scope and make sure you see pass. If you see pass, you can just press the fire button, return to the main menu. If you see fail, try it again. Make sure you're facing north, go through the points nice and slow and steady. If you repeatedly get a failure message, go and do the tilt calibration first, and then come back and do the compass cal. That should do it. That's the compass cal for the TruPulse 360, 360R.
So I'll throw it back over to you, Aaron.
I will pick this up just a sec here, and I will show my screen. So in our demonstration, I'll jump out of the PowerPoint and click around a little bit. So we're going to just kind of circle back, talk about what we collect with the TruPulse Traveler Survey. Again, circle back on the benefits of why it's a great solution for certain projects, and then we'll introduce how that appears in our RoadEng interface, how we work with it, how to connect your TruPulse laser. Calibration was already covered, and then we'll take some shots with it and and to show how we can incorporate that down the line and build a surface off of what we collect in our survey module and use that in a design. So let's just pull this over and our topo surface here, this isn't a traverse surface that I'm showing here. This is a LiDAR surface. LiDAR is great if you have it, but usually when it's required for a landscape level area, so large areas, and it can be quite expensive to acquire. So if you have budgetary issues, or if you're looking at a small-ish area that your project's located in, then it's probably not practical to go out and have someone fly it. Now, the other options, as mentioned before, are your traditional survey data types. So total station and RTK surveys would be another example. Now, RTK surveys aren't great under Canopy. You'll lose connection with your receiver and you won't get that extra accuracy. And it's also a really expensive piece of equipment to have. And then from a total station standpoint, using a total station in the field, could, especially in a forestry setting, can be time consuming. You need at least a two-person crew. To do a survey for a road, you're going to be traversing with that total station. You're going to be lugging a lot more gear with you. And to do that traverse with the total station, you're swapping back and forth, moving your tripod, total station around a whole bunch and resetting up. So it's really time consuming, and then you're brushing a lot of your area as well just to get those shots. Now, with the traverse data, it's nice because you can just get what you need. So it's specific for your linear infrastructure. So we'll sequentially shoot our centerline shots, and then we'll collect side shot data off of that, and we'll use that to generate our surface. So we'll keep the LiDAR data in the background here. Just give it a moment to recalculate, and there we can see what our result is going to be with that traverse data from a laser. Now, when we collect this, it's largely a tabular exercise. And here we've got our traverse file in our survey module, and we can see that we've got our station 0, we've got our 4-shot ahead, so our azimuth, and then we've got our slope distance, calculates horizontal distance, put in the slope, and then for our cross-section geometry, we can just add that in here as well. See, we have our cross sections at each one of those stations. We can double click here, and that's that cross section geometry that's used to give us our 3D points that we generate our surface from. Now, traditionally, this is done, really traditionally, it's done with a notepad, a tight chain, and compass and clinometer. Now, notepad, you get the opportunity to re-enter your measurements wrong twice, so entering them in the notepad and then transcribing them over into our software. If you're a little bit ahead of the game, you can do that with a data logger, enter it in our application, and you get one opportunity to mess up what's entered in there tabularly. Nice thing about the laser finder is we can log those shots automatically. You need fewer pieces of equipment. You're juggling around less things when you go from point to point. It's fast. You don't have to drag a tight chain through the woods and find the shortest line. You can just, Buddy can find the easiest path to walk to the next shot, and then get that next shot on him if he's got his prism or reflective piece of tape if you're using a brush filter. So getting into the nuts and bolts of what we hope to talk about here, the laser side of things. If you're using a laser with our software and you would like to have everything happen automatically for you, it'll have to be run on a Windows device. So commonly a Windows Surface tablet with Windows 10. And then for that, to connect to our device, we'll, same as really anything for a Bluetooth connection. We've got our devices and add Bluetooth device. Click that and you have to turn it on in your rangefinder as well. So you only have to do that once. It's going to retain the settings when you open it up next time. It'll automatically be paired. So just set that up here, and on your thing, hold down, on your rangefinder, hold down the down button, I think for 4 seconds, toggle to the Bluetooth page, and enable it. And then you're connected with your computer or tablet. Now, to connect that to our application, we'll just come over here, we'll hit connect, and mine's set up on COM port 3. Usually you don't have many COM ports. I figured out what mine was on just by trial and error, and I'm sure there's another way to do it, but it seemed pretty slick for me. We'll hit OK, and we're connected. Now, just if you want to have your traverse geo-referenced as well, now I don't have a GPS connected to this, but I can connect to my location services, and I can click that on as well. So when we start our traverse, we can geo-reference it. So I'm just going to start a new traverse. Hit OK. To set our coordinates, set from GPS. Great. And if you don't have to do this in the field. If you don't have a GPS with you for some reason, you could just take a GPS point and manually put those coordinates in after the fact, or at any point really in your traverse. So we've got that set up. Here we have our new blank traverse file. Now, again, just circling back to the traditional approach, we'd manually go in here and type in, let's go 12 for 5, then 20, make it more noticeable for my fictional side shot, and then 45. Click draw, and we can see we've got that cross-section geometry accounted for. Same on the other side. We can do -50 and click draw, and away we go. So we manually put in our measurements, same for a foreshot, slope distance, etc. Now, if we go to the rangefinder, if I just hold that up to my eye, click and hold the button for fire, this little dialog box appears, and it's got all those measurements that I just shot with my rangefinder, no jumping back and forth with different instruments. So, and we can see I can either click enter shot, or the next trigger press on the laser will automatically accept this data. So there we go. Yeah, and you can continue along through this. It's largely just a matter of clicking the fire button. One thing you may have to adjust is the shot type. So we do have multiple shot types with this. So here it's side shot left IFS, so that's intermittent foreshot. And we could choose it to be something else entirely. So we could do another foreshot, or that gets logged out as a foreshot. We could do a radial shot, and that radial shot is going to be, these foreshots are sequentially along your center line. Your side shot left, side shot right are perpendicular to your center line, and these radial shots are coming off of your center line at whatever azimuth you've measured. So it's it is, and let's turn off our GPS so we can show where we're at in this one. It's these guys here, which are radial shots. They're not necessarily perpendicular. They can be at whatever you want. So I don't think there's much of a benefit of going through and doing a bunch of shots to fudge in a survey when we have an actual survey here. we'll just jump ahead and open this up in Terrain. We'll build a surface from it, and then we'll show you how you bring that into your design file. So in Terrain, this is going to open up on my other screen. Just a sec. In Terrain, we'll click Insert File. We'll grab the TR1 file, so that's our survey file. We'll hit OK. Choose whether you include side shots or not. If you're using it for the survey surface, you're going to want to include your side shots. You can set your coordinate system to whatever you'd like it to be. And there we are. So there's our center line, side shots. We've got the radial shots in there as well. Model that surface will come over here. I'm going to set the range to be appropriate. There, we've got our surface from the traverse. You can see what it is we're working with. We'll save that as Topo 2. Then we can come over to location, and we can reference both those files. So there would be no problem just designing this with a terrain file, or just designing it with the traverse file itself, so the TR1 file. Using both is nice because we've got the contours that we've just generated for added context for where our surface is, and then having that TR1 file in there is nice to get your horizontal offsets relative to center line. We're going to click New. We're going to grab that terrain file. We'll add a P-line as well, which is the survey itself. We'll hit OK. And there we are. We can see we're ready to design. I'm not going to go into the details of design. That's not really our focus today. But we can really quickly get a really good design off that survey that was collected with a rangefinder. We can see that there. See that there. And in this case, my current point is offset from my P-line traverse, and we can see that horizontal offset here and tabularly get the measurements there. Yeah, so that's what I was hoping to cover. And
awesome.
Yeah.
So I can assume that we possibly covered a few questions while I had my internet outage. Did we?
Nope.
Oh, we didn't. Oh, wonderful.
Nope.
Oh, I thought that's what you guys would have defaulted to. Okay, well then we got a whole bunch. So first question here, does your warranty meet or exceed Vortex and Leica? So I'm going to pass this question over to the guys from LaserTech. Derek or Steve, would either one of you mind fielding that one?
Yeah, this is Derek. Our standard warranty on all laser rangefinders it's 2-year warranty. So we have a 2-year. So I'm not sure how that stacks up against the other ones you just mentioned, but we do have a standard 2-year warranty on our products.
Excellent. Okay, so this one seems to be more of a comment, but I'm going to just read it out as well. I think this is going back to looking at your filter mode. It just says you definitely want to be careful. Reflective tape does work, and this includes reflective strips on survey vests. It's more of a cautionary tip from one of our watchers, so thank you for that. I know, Steve, Derek, do you want to comment a little bit on it?
That's a great tip. Yeah, oftentimes the guy going ahead to set the target or something like that may have reflective tape on the vest, so that's something that you definitely want to consider when you're using that mode. Yeah.
Excellent. Next question. Will the new 200 laser work with RoadEng? It has Bluetooth and works with worksite software, but not sure if it will work with RoadEng. perhaps I might pass this one back to you as well, Steve.
I think, Aaron, I think they're talking about our new TruPoint 200H laser that we have.
Potentially, that sounds like it.
Yeah, we've got a new laser that we've introduced that does work with different apps like Worksite that we've developed. And I'm not quite sure if you guys have written that in there, but it would still be able to do, like using a TruPulse 200 and a compass, you can get those measurements and then manually enter that information in. I do not believe it's a seamless laser integration at this point.
Something obviously that we can maybe come back and test a little bit more into the future.
Correct. Yeah.
The next question is, can I use the TruPulse to calculate clearance?
Yeah, we do. Yeah, go ahead, Steve.
Yeah, Derek mentioned a couple of other onboard routines we have. One is for height and the other we call missing line. And that's a great one for clearance. It's like shot 1, shot 2 to your 2 targets, and you get all the information between them. So if you're using a 200 laser and that kind of 2-dimensional thing, then you want to make sure your 2 shots are in line with one another, so to speak. If you're using the 360, you have more flexibility. You can shoot the points anywhere and you'll still get good data between the 2.
Do you know what? I think we had a slide actually that we pulled out of our presentation. Let me see. I may have put it here in the back. Let's see. Oops. Wrong way. Haha. You did have this in, and I cut it. So sorry.
That's all right. That's a perfect application, though, so the attendee can see what's going on. Yep.
Excellent. I've got a couple more questions here. Could I combine the TruPulse survey with some USGS DEM data that I picked up off of Earth Explorer? Matt, I might send this one your way.
I think I can tackle that one. Yeah, absolutely. So another kind of, we talked about collecting all your surface data with the laser in the example I went through. But you could augment your surface data from the USGS DEM as well. But another really useful thing is if you're looking for field marking your road and you want to have those offsets, you can take a traverse file, use your center line that was your conventional traverse, pull the surface data from your LiDAR data, and combine the two for field marking and reference for the design.
Awesome. Well, hey, I might just call it there. We've got a little gap before people type in more questions. So I just want to say first off, thank you to our presenters, Derek and Steve from Laser Technology, Inc. Thanks to Matt. Per usual, you're kind of our resident webinar guru here. And thank you to all for joining us today. Be sure to, check out more upcoming webinars. We will be updating our calendar here in the next few days, so lots of new ones coming out and getting added. So thank you all so much, and apologies again for my internet outage. Yes, dreadful to happen during live webinars. So enjoy the rest of your day. See you all again soon.
Thanks, everyone.
Thanks for watching another Softree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.